Hello, my name is Darren Thomas, and I am the Director of Educational Research Techniques. In this video, we're going to be doing some more about approximating the area under a curve, but this time with a right endpoint. So let's go ahead and get started. So if you look off to the right here, no pun intended, right endpoint, look off to the right, you can see that we have here our actual graph that we're trying to deal with today, our function. And so this function is essentially nothing fancy here, just, f of x squared. That's it. And so we're trying to find the area under the curve where it goes from 0 to 2. This should be a 0. Like so. So basically, we want to go from here and get all this stuff right here. That's what we're trying to get right there. Let me go ahead and clear. So we've already done left endpoints. And so the only difference between left endpoints and right endpoints is where the actual rectangles that we're going to use, where they touch the function of the line, if you will. And so remember that there are several things we need to do. First, we need to figure out what is our n. In other words, how many pieces are we going to divide our little shape here into? And so for our purposes this time, our n is going to equal 4 again. So n is going to equal 4. You've seen this before if you watched the previous video. And so now we got to calculate our delta x here. So our delta x is going to equal b minus a. So b is going to be where the last part of our line is at, our area, and a is going to be the beginning, like so. So for our purposes, b is going to be 2 minus 0, because that's where we're going to start at, and it's going to be over n. And since our n is 4, we're going to put that right here. And so now we know that when we work this out, our delta x is going to equal 1/2. In other words, we're going to draw a little triangle, excuse me, not triangle, I like to say that. We're going to draw a rectangle 4 times that has a space of 1/2, if you will. So let's see here. Now I want the right to touch. So let's see. It would be something like this. Like that. And then I want to go up again, make sure that should be the right. Let's see here. Like that, that's the right again, like so. And then up here like this. Again, that's the right. And then finish it like so, like this. Okay, now one thing that I need to mention is that when you do the right end approximation, it really depends on the function, but in this case, compared to what we got in the last video, we're going to overestimate, because you can see that we have a lot of rectangle that is above the line here. When you use the left hand in this particular type of a function, you're going to under approximate. And so between the left and the right, you have an ideal of the area. It kind of gives you almost like a confidence interval, if you will, for those of you who are familiar with that. So this is what we're doing. You can see we have 1, 2, 3, 4, just like so. And now what we have to do is we have to start dealing with finding the sides of each one of these rectangles, if you will. So this is what we're going to do. So where is my guy touching? My rectangles are touching at these points right here, like so. And so my x1, again, let me slow down here for a second. My first f value, in case you've forgotten, is going to be f of 0.5, because that is where it touches for the first time on the line. And so if I work that out, and remember, our actual function is x squared. So if I square this, I'm going to get 0.25. That's what's going to happen. So it's going to be 0.5 squared. That's going to equal 0.25. If I continue with that ideal, where's my second little dot at? Is going to be at 1. So there's not a whole lot going on there. If you square 1, you get 1. Now if I do my next one, it's going to be 1.5. And if I square this, you know that I'm going to get 2.25, like so. And then my last one is going to be f, is going to be right here at 2. And so if I do this one, I'm going to get 4. So those are the values that I have. In other words, that is the height for each one. And so now what I need to do now is that I need to take base times height and do that for each of my 4 rectangles. And we've done this before in the previous video. And so here's how we can do this. So if we had to say, and this is kind of the common notation here, we're going to do R4. Now, the last time I multiplied delta x by each one, but there's a shortcut. And so I'll show that to you right now. If I just do 0.5 on the outside here, and then I put inside brackets all of my information. So for my first one, it's going to be, our first value here is going to be 0.25. 0.25 plus, let's see here, 1 plus 2.25 plus 4, like so. And then we multiply all that by 0.5. So let's see here. We got 2.5 is going to be 1.25 up here, like so. And then that's going to be 3.5, and then 3.5, 7.5, like this. And then, of course, if you take 7.5 and you multiply by 0.5, you're going to get a final answer, which is going to be right here. It's going to be 3.75. So that is the estimated area under the curve when you have a right endpoint for the approximation. And so that's how it works. Now, I want to kind of go back and explain what we talked about and then wrap this up. So in this video, we were looking at how to approximate the area under the curve using the right endpoint. And by right endpoint, we're talking about where on the graph the actual rectangle touches the function line. And so this is shown to you in this light blue here on the actual graph here. Now, what you need to do is that you need to figure out, well, what is your interval going to be? And that's going to be b minus a over n. So you have to know what your n is first, how many, what you're going to divide it up to. And that'll kind of give you the width of your rectangles, if you will. So the width of my rectangles is 0.5, as you can see right here, or you can say 1/2, however you want to see it. And then once you do that, you just plug in for your values wherever the rectangle touches the line from the right. And so you can see right here, every single time from the right, that's what I plugged in for my original function, which, like I told you, was x squared. So I plugged in 0.5 because that's the x value where if you go up, it touches on the line right there. And so you do that for the 4 times because our n is 4, and you get these values all right here. And then once you have that, you have to take these values, add them up, and then multiply them by the actual base of each rectangle. So that's what we did, and we got an answer of 3.75. Now, in this particular situation, when you're dealing with this type of a function, you're going to overestimate the area under the curve when you're doing a right endpoint. If you do a left endpoint, you're going to underestimate it. And so calculating the left and the right can give you a better sense. But of course, there are a better sense of what the area under the curve is. However, there are other methods of doing this that we're going to see in future videos. So my name is Darren Thomas. I am the Director of Educational Research Techniques. Thank you for listening and watching. If you like this, please subscribe and give us a thumb up. Take care.